Assalamualaikum class. In this video we are going to start chapter number 2, the dot and cross product. At first we will discuss about the dot product, which is also named as a scalar product because the resultant of the dot product is always a scalar quantity. The dot product or scalar product of two vectors is denoted by a dot b, and it is defined as a dot b is equal to magnitude of a into magnitude of p into cos of theta, where theta is the angle between a and b, and here is the condition that we have to impose on theta, that it must lie between 0 and pi. As we know that cos is a periodic function and it repeats its values after the period pi, so that's why we have imposed the condition over here. And we also know that the range for cos is -1 to 1, that is the maximum value holds for 0 and the minimum value holds for 180 or pi, so which is -1 over here, and all the values lie between 0 to pi, and after pi it started repeating its value. That's why we have imposed the condition that theta must lie between 0 and pi. Now there are some here we will discuss about the representation of a into b cos theta, or what is the geometric representation of the dot product. As we know that for the right angle triangle, here is the right angle triangle with base A, perpendicular B, and hypotenuse C, and theta with the base angle. So clearly cos of theta will be equal to A over C, that is base over hypotenuse, and A is equal to C cos theta. So here you can see that if you want to calculate or if you want to measure the length of the base, we simply multiply the hypotenuse with the cos of the angle between base and the hypotenuse. Or if I multiply cos theta with the length of hypotenuse, I got this base length or this horizontal length. Or you can also see that this is the base is basically the projection of this length C on the horizontal surface. So this is basically the projection on the horizontal surface. Similarly, if I come to the dot product, which is a dot b is equal to ab cos theta, and if I discuss about this b cos theta, so here is the b cos theta. You can see that if this is my angle a, vector a, this is the vector b, and we are taking the dot product between the two vectors with angle theta. So how you can easily see that if I draw perpendicular length over here, this will be the projection of b on a, and if this is assumed to be right triangle, this must be equal to b cos theta. So it means that projection of vector b on vector a is equal to the length, which is b cos theta. And if I want to represent it in terms of the dot product, so I can easily write it as b dot unit vector a, because the dot product will be equal to b cos theta, because it will be equal to magnitude of b into magnitude of unit vector a, which is 1, into cos of theta, the angle between b and a. So it will be equal to b cos theta, which is basically the projection of b on a. So this is how the dot product helps to define the projection of a vector onto another vector. So projection of b on a will be equal to b dot a, that is we have to take the dot product of the vector with the unit vector of the other one. Here are some properties of dot product. Number one is the commutative property, that a dot b is always equal to b dot a. Clearly it is holds for dot product, because a dot b is equal to ab cos theta, and if I calculate b dot a, it will be equal to b into a into cos theta. As we know that the product of scalars is commutative, that's why a dot b, a into b will be equal to b into a. That's why both are representing the same scalar quantities, so we will say that a dot b is equal to b dot a. Next we have the distributive law, that a dot b plus c is equal to a dot b plus a dot c, and we will prove it as well. So now we are going to prove the distributive law for dot product. Like let's suppose this is the vector b and this is the vector c, and if I add the two vectors by head to tail, or this is going to be the vector b plus c, and let's suppose this is my vector a. So as far as the a dot b plus c, it means we want to talk about the projection of b plus c on a. So here is the projection of b plus c on a, which is equal to, here you can say this is the vector b, so this is the projection of b, and this is a projection of c on a. So clearly projection of b plus c is equal to projection of b on a plus projection of c on a. So I can write it as projection of b plus c on a is equal to projection of b plus projection of c on a. Now we have discussed that projections is represented as the dot product of the vector with the unit vector of the other one. So here we can see that b plus c dot unit vector a is equal to b dot unit vector a plus c dot unit vector a. Now we will multiply the scalar number, which is the magnitude of the vector A on both sides of the equation, and we will get B plus E dot A is equal to B dot A plus E dot A. This is what we have to prove in this property. Next property is quite obvious, which is basically for scalar multiplication, that we can multiply a scalar m with the dot product in any way. Like we can multiply with the resultant of a dot b, or we can multiply any of the vector first and then we will take the dot product, so it represents the same scalar at the end. Then we have the fourth property, that I dot I, j dot j, k dot k is equal to 1. And why this will be equal to 1? Because by definition I dot I will be equal to magnitude of I into magnitude of I into cos of 0, because 0 will be the angle between I and I. So the magnitude of unit vector I is 1 and cos of 0 is 1. That's why we are having 1. Similarly, j dot j, k dot k will be 1. But when I take the dot product with any other one, we know that I, j and k are at right angle or are making a 90-degree angle with each other. So I dot j will be equal to magnitude of I into magnitude of j into cos of 90 degree. Cos 90 is 0, that's why resultant is 0. So I dot j, j dot k, k dot I will be equal to 0. The next property is saying that if A is equal to the vector a1 I cap, a2 j cap, a3 k cap, then you can see A can also be represented as A vector is equal to a1, a2, a3. That is, the x component is a1, y component is a2, and a3 will be the z component. So A dot A by definition will be equal to magnitude of A into magnitude of A into cos of 0 degree, which is 1. So A into A is going to be A square. So here is the result, that A dot A will be equal to A square, and A square is basically the square of the magnitude will be equal to a1 square plus a2 square plus a3 square, because the magnitude is calculated as the square root of a1 square plus a2 square plus a3 square. So here is a very important result, that we can find out, or we can calculate the dot product of any vector with itself by simply multiplying the corresponding components, or by simply taking the square of the magnitude of that vector. Now we will try to find out a result, or we will try to derive a result for further dot product of any two vectors A and B if we do not know the angle between A and B, but we are given with the components of A and B. So rather than to find out the angle between A and B and first and then to calculate the dot product, we will go for a method or a technique by which we can find out the dot product of any two vectors, even though if we do not know the angle between them, but we are given with the components of the vectors. So let's suppose the vector A has the components a1, a2, a3, and B has a vector B vector has components b1, b2, b3, and we will calculate A dot B simply inserting the value of A and B over here. Now we can apply the property that A dot B plus C is equal to A dot B plus A dot C. So we will apply this property over here. So, and we will take the dot product of this vector with this one, then a2 j dot with the whole vector and this one, and then we will again apply the property. We will left with I dot I, a1 b1 I dot I, a1 b2 I dot j, a1 b3 I dot k. Similarly this one, when we open up this bracket with a2 b1 j dot I, a2 b2 j dot j, a2 b3 j dot k, and the same holds for the third one as well. Now we have checked that I dot I will be equal to 1, so we are left with a1 b1, a1 b1, I dot j will be 0, I dot k will be 0, j dot I will be 0, and j dot j is 1. So in the next term we will have plus a2 b2, again j dot k 0, k dot I 0, k dot j 0, and k dot k is equal to 1. That is, the next term will be a3 b3. So we can say that A dot B is equal to a1 b1 plus a2 b2 plus a3 b3 if we are given with the components of the vectors. We have just multiplied the corresponding components and then we will add the answers. Next we have the sixth property, that if A and B both are not null vectors. Not null vectors means they are non-zero vectors, or their magnitude is not equal to 0, but we are given with their dot product is 0, then the A and B will be perpendicular. And how these are perpendicular? As we are given with that A dot B is equal to 0, that is A B into cos theta is equal to 0. Now it is also given that both are not non-zero vectors, both are non-zero vectors or the non-null vectors. So A is not equal to 0, B is not equal to 0. It means cos of theta is equal to 0, which is showing that theta is equal to 90 degree, because theta is lying between 0 and 180 degree. That's why we will say that whenever two non-zero vectors are having a 0 dot product, it means both are perpendicular vectors. Now we will solve some questions related to the dot product. We are done with question number 1, 2 and 3 in the discussions. You can check out these easily, and you have to attempt question number 4 by yourself. It is already solved over here. You just need to go through the question. Next we have question number 5, and we are already done with A, B and C part, and here is the part D, that j dot 2I minus 3j plus k, that is we have to find out the dot product. So you can see that there are two methods to solve this. Number one, we can apply the property that this is going to be j dot I minus 3 into j dot j plus 1 into j dot k, and then these two will be 0 and this one will be 1, so answer will be minus 3. Or you can apply the rule for the dot product. We have recently discussed that in order to find out the dot product of any two vectors given with the components, we just need to multiply the corresponding components, then we will add the numbers. So you can see that this vector is having only one component, that is the j component, so we will multiply the j component with the j component. 1 into minus 3 is minus 3 will be the final answer, but it's totally up to you, whatever you want to choose the method. Then we have question number question number 5 part E, 2I minus j dot 3I plus k. Again we have showed that we have used the property over here, that a dot b plus c is equal to a dot b plus a dot c, or you can use the result as well, in which you do not need to perform all the calculations. We will just multiply the corresponding components. So I component will be multiplied with I, that is 2 into 3 will be 6, plus j component is 1, but right now j component is not present over here, so that is 0, so 1 into 0 is 0. Again k component is present over here but not here, so k component is 0 over here. 0 into 1 is 0, so 6 will be the answer in this case. We are already done with question number 6 and 7. Next we have question number 8. Find the angle between A and B. The vector A is given to us and the vector B is also given to us. Now we know that A dot B is equal to AB cos theta. We can easily find out A dot B by multiplying the corresponding components of the two vectors. We can find out the magnitude of A and magnitude of B, and then we can easily find out the angle, cos of the angle theta. So we will first calculate the magnitude of the vector A, which is 3, and magnitude of vector B, which is 7. Now inserting the values over here. Before that we will calculate the dot product A dot B, that is we will multiply the corresponding components. So 2 into 6 plus 2 into minus 3 plus minus 1 into 2, so here is the answer, which is 4. So inserting the values over here, A dot B will be equal to 4. A into B is 3 into 7, so here is the corresponding angle theta over here. We are already discussed question number 9, that whenever A dot B is equal to 0 and A and B are non-zero vectors, then they must be perpendicular to each other. Next we have question number 10, in which we have to determine the value of scalar alpha, scalar A, where A vector is given to be 2I cap plus AJ cap plus K cap, and the vector B is also given, and both vectors are perpendicular. So if we are given with the condition that both vectors are perpendicular, it means we can say that A dot B will be 0. So A dot B will be 0. Now we can calculate A dot B by multiplying the corresponding components. So here is A dot B, which is equal to 0, which is showing that A will be equal to 3 in this case.